Welcome. Today, we're moving beyond the simple party trick of spot the AI photo. For us, as engineers, scientists, and architects, the distinction between real and synthetic data isn't just a curiosity. It's a fundamental challenge that impacts everything from data integrity and model training to system security and user trust. The rapid evolution of generative models, from generative adversarial networks to the incredibly potent diffusion models like Midjourney and Stable Diffusion, has blurred the lines to an unprecedented degree. This isn't just about images. It applies to text, audio, and even tabular data. Our goal today is to dissect the technical underpinnings of this challenge. We won't just look at what gives AI away. We'll explore why these artifacts exist, how detection models work, how they can be fooled, and most importantly, how we can build robust, production-grade systems that are resilient in this new landscape of synthetic reality. Let's begin our deep dive. So, how can we spot the digital ghost in the machine? The most obvious tells are rendering artifacts. Early GANs, for example, often left behind subtle, high-frequency checkerboard patterns due to the upsampling layers in their architecture. While newer models have mitigated this, they have their own tells. Diffusion models, for instance, build images from noise and can struggle with maintaining long-range logical consistency. This is why we see issues with complex anatomy like hands. Counting fingers requires a global understanding that can be difficult to maintain. The same goes for rendering coherent text. But the real deep dive goes beyond the visual. In the frequency domain, Fourier analysis can reveal unnatural periodic patterns that are invisible to the naked eye. And when we talk about synthetic data, not just images, we look for statistical fingerprints. A common failure mode in tabular GANs is mode collapse, where the model overproduces common examples and fails to capture the rich diversity and long-tail distributions of a real-world dataset. These statistical divergences are crucial tells for any data scientist. Building a reliable detector is not a one-and-done task. We're in a constant arms race. The very nature of a generative adversarial network involves a discriminator trying to tell real from fake. This means every new generation of models is inherently trained to be less detectable. This leads to the concept of adversarial examples specifically for detection models. An attacker can introduce minute, carefully crafted perturbations to a generated image that are imperceptible to humans but cause a detection algorithm to misclassify it as authentic.